Okay, we are live, and we continue solving neetcode binary search. So today's task is about this one, and so let's check. So we have search in rotated sorted array. So what do we have? We have an array that is sorted, but it can be rotated. So we see that it's sorted, but it's rotated. And we have some target value. So here it's 0. So 0 means that it would be on the fourth index. So we have to return this index. Here, for example, when it has 3, we don't have this element in our array, so we return -1. And we also return here -1. We see that it has at least one element, values from negative to positive. They are unique, and target as well. All right, so let's think about test cases. So when we have something like 1, 2, 1, 0, and something like this, let's say like 5. So we have rotation, and we have, for example, target 5. And in this case, we should return 2. What if we have target 4? Then we should return -1. Yeah. So what different values can we have? So we can have something like this, right? Or we can have something like this. Or we can have something like this. Yeah, so we have this 0, it can be here, it can be here, or it can be here, like, yeah, it's rotated in different directions. Okay. So what our logic? Our logic is the following. So we check the middle element. We check the middle element. It's 7. And what we also can check, we can check this value. And it's 9, right? So if it's 9, it means our value is rotated. So and here it's 2. So that also means that our value is rotated. Because if we will check like here 2, and our left value is less than the current value, that means it's not rotated. And and here as well. And here, if we check like 1, it's 8. Here's 5. So here it means that all values Yeah, so our logic is the following. So we check our middle element and we see like what would be the ranges. So ranges between 7 and 9 or ranges between 2 and 7. So if our value is between these ranges, then we go binary search here. If between these ranges, then we go binary search here. As well, like here. So we trying to find 1, for example, we check 0 and 2, and it would be our ranges actually. Here we are on 1, and we try to find 4, for example, so we are in these ranges. So from 1 to 8, or from 1 to 5. Here from 7 to 8, from 7 to 9, or from 2 to 7. Yeah, 0, 2, 2, 5. Okay, and now what we are doing now. So yeah, so I believe we can start with this logic, and it would be binary search. So here we have left -1, and we have right nums length. While r minus l is greater than 1, then we do some logic. Here we try to find mid, so we r minus l divided by 2 plus l. And we have mid value. It would be nums mid. And also we have left and right value. It would be nums l plus 1, and to right value it would be r minus 1. Okay, so what can we do? We can check if our mid value is equal to target, then we return mid index. If not, then then what can we do? We actually check. So as we can see, we can have a left is greater than the current mid value. So we can check what we can check. Yeah, because it can be also rotated like this. Yes. And here, for example, we are checking that left is greater, and we check if it's in this range. Yeah, so how can I do this? Let's think, how can we do this? Uh, 0, 1, and 8. 1 to 3. From 1 to 8. Yeah, but for example here, if I want to try 0, to find 0, like I check 1, and I can check 5. Yeah, so if it's greater, then I just go, yeah, and if my target is there, I just go there. Let's check. So if mid value is less than right value, and target and yes, and mid value is less than target, and mid value is less than right value, then I go here. So I move my I move my left pointer. L will be equal to mid. Else if, so I cover this case. Okay. Um, okay. Now, if it's not here, then I move my right pointer, right? So for example, here. And yeah, it doesn't matter. Yeah, I cannot check it like this because I am just missing 0. So mm, yeah, I think in all other cases probably I should move right pointer, and here return -1. Let's check. Let's check. Run. Okay, target 0. So 7. Okay. Here I should move my left pointer. So else if my mid value is greater than left value and target is greater or equal left value and target no, if mid value is greater than left and target is greater than mid value, is greater than L value. No, it's less. Yeah. If target is less than L value, so mid value is greater than L value, left value, right? So I have this sorted range, and target is less, then I just move my left pointer. Run. Okay. Try to submit it. Okay, so we have here 3 and 1. So I check 3. Yeah, here I think that we should not return -1, but when we are standing, I'm thinking whether like mid value, right value. So I move my left pointer. So I can check like if left pointer not equal to -1, left pointer not equal to -1, yeah, what I need to check, I have like 2 pointers. If my left pointer not equal to -1 and nonce L is equal to target, then I just return my L. The same I'm doing with right. If it's not equal to nonce length, yeah. So I'm just checking these 2 cases. Here I can check this case. Output -1. Okay. Let's print what we have here. -1, 0. So we are moving right pointer here. Okay. Yeah, so let's check how it works. So we calculate mid value. So right would be 2, plus 1, 3, divided by 2, 1, so 0. So we check 3. So it would be 0, 3. Left value. Left value 3. Right value. Left value 3. Right value 1. I think that actually I can check like if L value is equal to target, return L plus 1. Yeah, I can maybe do this 2 checks as well. And I think I don't need that. Have this one. And it should work. We'll check. Yeah, it works. Mm. 8. Okay, so I have 7. Yeah, I have 7 and I have this logic. So here I check like right value is not here. Then mid value is greater than L value, right? Target not. Yeah, it should be like this. So target should be less or target greater than mid value. Something like this, I believe. Let's check. Yeah. Okay. Okay, so we solve it, and if we don't use this one, would it also work? No, not works with this one. Okay, so I think we solve it, but as we see, is like a lot of problems. And let's check solutions. Yes, some complex one. Okay, mid. Num. It's with some infinities. Target. Yeah, also we see that they have the same logic. With like nested ifs. We just don't have it nested ifs. It's simpler, I think. But a lot of ifs, I think, yeah. So it's not optimal, actually. Let's check our submissions. So we have like submission a long time ago. So I have some submission linear time. Yeah, so today we actually solve it in binary search. So see you next time.